right, well, why don't we do a lesson as long as you're here? Um, I guess we'll talk about division of exponents today. All right? Okay, so yesterday we talked about multiplying numbers with exponents, and today why don't we talk about dividing numbers with exponents? Let's choose a couple examples. Let's say that we had x squared over x, or x to the first. Do you see what this is really saying? Again, kind of like yesterday, just to visualize what's happening when you have x squared. We have x times x over a single x. You can break this up. Think of this as two different factors, and whenever you have the same factor over the same factor, that's like a 1. So this ends up being 1 times x, which is just x. So whenever you have the same thing over the same thing, it just goes away, it cancels. So do you see that x squared over x to the first, what you end up doing is you take the exponents and you subtract them. The rule is x to the a over x to the b equals x to the a minus b. Stop and think about that if it doesn't make sense. Let's take another example, a little more complicated. Let's say that we have a to the fifth, b to the sixth over a to the fourth, and b cubed. So you can do it two different ways. Do it the subtraction method. A to the fifth over a to the fourth is going to be a to the 5 minus 4, which is just simply a, right? And b to the sixth over b to the b cubed is going to be b to the sixth minus 3, which is b cubed. I kind of tend to prefer, instead of the subtraction method, visualizing it. So a to the fifth up here is going to be 5 a's multiplied together. A times a times a times a times a. And b to the sixth is going to be 6 b's multiplied together. B times b times b times b times b, and we're going to run out of room, times b. And then down here, same thing. We're going to have 4 a's and 3 b's. I'll just do that all at one time. A times a times a. Now, this a is going to cancel that a, that a, that a, that a. This b is going to cancel that b, and that b. So it leaves me with 1a up above in the numerator and 3 b's up above in the numerator. So I get ab cubed. Either way that you think about it is totally fine. I tend to be a little more visual, so this is better. But the subtraction thing works totally fine also. An interesting thing happens when we have the same thing over the same thing. What if we had x to the fourth over x to the fourth? Do you see that when you subtract, you're going to get x to the 4 minus 4, which is x to the 0. And the other way to think about it is x to the same thing over the same thing. Everybody's going to cancel everybody down below, and you're going to get 1. So what you find out when you try this enough times is anything to the 0 power equals 1. I shouldn't say anything, because 0, you can't do that, because remember how we talked about you can never have 0 over 0? So that's impossible to do. So any non-zero number to the 0th power equals 1. So the general rule is anything, if a is anything except 0, and you raise it to the 0 power, it equals 1. Even if it's a number. 5 to the 0 power Might seem a little strange, but that equals 1. Because if you think about what's happening, let's say it's 5 squared over 5 squared. Well, this is 1. We know that it's the same thing over the same thing. But it's also 5 to the 2 minus 2, which is 5 to the 0th power, so you can prove that it equals 1. Even really complicated things, if you raise them to the 0th power, can be 1. X squared, y to the 5th, over z squared, and you raise that whole thing to the 0th power, that equals 1. By the way, when they put a power outside of the brackets, every single person inside gets that power. They cover that in this chapter, but it's kind of more of a minor point, but let me bring it up now. If you have x squared over y cubed and you raise the whole thing, you square it, that means this gets squared and that gets squared. So it's going to be x to the 4th over y to the 6th. Okay? If there was a number inside here, that would also get squared. So then it would be 4x to the 4th over y to the 6th. Okay, we have one last thing to do. I hope you can stick with me here. It's a sunny, beautiful day, so why not? Another interesting thing happens when you have a smaller number of exponents up above over a larger number down below. Remember, if we do the canceling thing, that's going to be x to the 2 minus 3, which gives you a negative exponent. Don't be scared. Okay, negative exponents, it's okay. You can see what negative exponent, okay, so here's one way to do it. It's x to the negative first. The other way to think about it is the canceling. Can you see this if I write here? X squared is going to be x times x. X cubed is going to be x times x times x. Two of those are going to cancel, leaving one down below. So that leaves me 1 over x. So these two things are equivalent. A more general way to say it is anything to a negative exponent is the same thing as the inverse of that, the reciprocal of that, to a positive exponent. So 1 over a to the positive exponent. Stop and think about it if that spaces your brain. I know that's a little bit of a hard concept. It's easier, honestly, to just think about the canceling. X to the 2nd over x to the 4th, y cubed, and y to the 5th. So you'll have x times x times y times y times y over x times x times x times x. Why did I choose so many? Okay? And then cancel, cancel. You're going to be left with 2 down here. Cancel, cancel, cancel. You'll be left with 2 also. So it's 1 over x squared y squared. And you could do that by subtracting also. You would get 1 over x squared, can't subtract there, y squared. The other way you can think of it as, sorry, this is not really truly the subtraction, is it? What I want is, I want x to the 2 minus 4 times y to the 3 minus 5. So this gives me x to the negative 2, y to the negative 2. These two things are the same. If you have a negative exponent, it's the same thing as the reciprocal of that, but you make the exponents positive now. So let's try one that has all these things mixed together. I know I've introduced a number of concepts. Let's try kind of a bigger one with a number of these things together. X to the 0, y to the negative 1, z cubed over x to the 4th, y to the negative 3, and z squared. Stop the tape. See if you can do it. Okay, could you handle it? All right, there's a number of different ways that we can think about doing this. So I've said this a number of times in class. What I like about math is that there's one right answer, but there's a lot of creative ways to get to that right answer. It's like climbing a mountain. You want to get to the top, but you can take a number of different routes. I'll do it one way, and then I'll try to come back and do it again if I can remember. In fact, so I don't forget, why don't I write it down real small over here? X to the 0, y to the negative 1, z cubed over x to the 4th, y to the negative 3, z squared. Okay, so method number 1. Anytime I see something to the 0th power, that's like a 1, and 1 times the rest of this is just going to be the rest of it. So I can just get rid of it. X to the 4th, I'm going to leave it down there. Y to the negative 1st over y to the negative 3rd. I could do this I'll do it one way first. I'll do the subtraction method. So that's going to be y to the negative 1st minus negative 3, which ends up adding the opposite. So you get y squared. Okay? So y squared is the result of these things on top of each other. And then z cubed over z squared should be pretty easy. That's z to the 3 minus 2, which is simply z. So why don't I combine this, make it a little neater. There you have it. We never write z to the 1st. We don't need to write that. That's just an extra thing. So don't do that. Just like we don't write 1 y squared z. Just don't do that. Okay? Another way to think about it. Let's write it over one more time. Okay. I'm going to start again by just getting rid of the x to the 0. Okay? And I'll leave the x to the 4th down below. Now, a negative exponent, remember, that can be the reciprocal of the positive exponent. So do that in reverse. If I put that y to the negative 1st down below, that's the reciprocal, right? Then it'll be y to the 1st. If I put that y to the negative 3rd up above, that's the reciprocal of it, then it'll be y cubed. So y to the negative 1 over y to the negative 3 is the same as y to the positive 3 over positive 1. The only reason I like that is then I know that canceling, one of those is going to cancel one of those. And I'll be left with 2 of them up above. 2 of these cancels 2 of these, leaving 1 extra up above. And there's my final answer, which is the same as before. Okay? We'll practice this tomorrow in class, so come ready to go. And yeah, have a nice sunny afternoon. Okay.